Hello, in this video we are looking at how we can prove that lines are parallel. And so we're going to be using kind of the information that we've been talking about, the different properties of parallel lines in a transversal, and we're going to kind of work backwards now. And so that's what we're going to be looking at. We're going to be looking at converse of our theorems. And a converse means kind of the opposite or backwards of it. So before we would say, well, if the lines are parallel, then these two angles are going to be congruent. But now we're going to look at, well, what if we know that these two angles are congruent, our corresponding angles, so 2 and 6, remember they're in the same position, so we could say that they're congruent. If they are congruent, then that's going to tell us that these two lines are parallel. So we're going to say if angle 2 is congruent to angle 6, then if those are the same angle measures, then the lines L is going to be parallel to the line M. And we're going to go through the rest of these theorems to kind of do that kind of same thing. These are in the position of alternate interior angles. So for the converse of alternate interior angle theorem, these are in the same position. If we know that these are congruent, if angle 4 is congruent to angle 6, then those two lines are parallel. So L is parallel to M. Now remember, with our same side interior angles, that didn't say that these are congruent, but it says that these two should add up to 180 degrees. So the converse of the same side interior angles theorem says if the measure of angle 3 in this case plus the measure of angle 6, if those add up to 180 degrees, then we know that L is parallel to M. And the last one we're going to look at is the converse of alternate exterior angles. So if angle 1 here and angle 7, if those are congruent, angle 1 is congruent to angle 7, or they have the same angle measure, then L is parallel to M. And so now let's look at a couple of examples, and these examples are going to look kind of familiar. We're going to be doing something similar to what we did when we were just looking at our properties of parallel lines. And so the first one is going to say, well, what is the value of x for A and B to be parallel? So remember, if A and B are to be parallel, these are same side interiors. So for same side interiors, those should add up to 180. If those add up to 180, then A and B would be parallel. So we're going to take 2x plus 9 plus 111 equals 180. So then the first thing that we are going to do is combine these two things. So we're going to have 2x plus 9 plus 111 is going to be 120 equals 180. Then what we are going to do is now solve. So we subtract 120 from both sides. Those cancel out. We have 2x on this side equals 180 minus 120 is going to be 60. And then we divide both sides by 2. X is going to equal 30. So if x is 30, then those two lines are parallel. Let's look at another example. Here we have 2x here and 120 here. We want to show that L and M are parallel. So if that's the case, these two are alternate Alternate interior angles. Alternate interior angles are congruent or the same, so these two things need to be the same. So if they are the same, we set them equal to each other. 2x equals 120. Divide both sides by 2. X equals 60. So if x is 60, then those two lines are parallel. The last thing that we're going to look at is we're going to have an image like this, and we are going to determine what lines are parallel. Maybe all 4 of them are parallel, maybe there's 2 sets of parallel lines, or maybe none of them are parallel. So let's first look at this symbol right here matches up with this symbol. Because they're the same, that means that those two angles are congruent. And so kind of highlight those a little bit. Those two are congruent. Now, we have to look at, and I'm going to ignore this line up here for the moment. Basically, we're trying to see are L and M parallel. And this is our transversal. As we look at this, we have to determine, do we have a relationship? Are they alternate interior? Are they alternate exterior? Are they corresponding? Are they same side interior? And we know that they're going to add up to 180. So I look at these, and I kind of see they're in the same position, so they're corresponding. And that would say that they are congruent. So because those are congruent, corresponding, then we can say that L and M are parallel. So L is parallel to M, and we know this because of corresponding angles. Now we want to determine if X and Y are parallel. And so this symbol right here, the 2 lines matches up with the 2 lines here. That means that those are congruent. I'm going to ignore this line M for just a moment. And so we want to see if these are parallel. So I look at this relationship, and these look alternate interior, and that they are congruent. So if they are congruent, then that means X and Y are going to be parallel. So X is parallel to Y, and that's because of those alternate interior. And now we're actually looking at the converse of all of these. I should write that with those. That's what's telling us that those two things are parallel. That L and M are parallel, and X and Y are parallel. All right, and that concludes what we're going to talk about with proving lines parallel.